Hi everyone, welcome to week 6. We're going to start with our little bit of sad news, Teddy and I. This is Teddy frowning, because this is going to be our last week together with me as your teacher, because another teacher has moved to, or is moving to Wellington to teach at a school down there, and so I am going to be teaching a year 13 bio class in the same time that I normally teach you. So you're going to get a new teacher, so probably smiley face on Teddy. You'll get a new teacher who is a chemistry teacher, so that's handy because our topic we're moving into is chemistry. I haven't met her yet because of lockdown, but I'm sure she'll be very nice. And I will be just up the corridor teaching some year 13 bio students in the hope that we're back at school. Anyway, on with chemistry. So our new topic is a chemical change topic. It's mainly to do with acids and bases and what sort of reactions they do, but the general idea is that there'll be some chemistry and chemical reactions taking place. We will be using some of the knowledge that you learnt at the beginning of the year to do with our periodic table of elements. So remember that elements are things that are made of atoms, and we learnt that atoms have a little model that we can use where they have different numbers of positive protons in the nucleus, and then they have the same number of electrons that go around the outside as they do the protons in the middle. They have 2 in the inner ring, and then 8 in the next ring, and then whatever's left over in their outer ring. So you'll be using some of that knowledge later in the topic. And then the first part of the topic is going to be about physical changes versus chemical changes. And so the physical changes are things you learnt last year. I have a picture somewhere. So in year 9, you would have done a nature and matter topic. You might not remember it, but you were learning about how things change from being in a solid state to a liquid state to a gas state, and back again, and what those changes were called and why they happened due to the nature of the molecules and how close they were together. So the beginning of this topic is looking at which things are physical changes like this, where even though they've changed their form, so from solid to liquid to gas, it's still water. It hasn't changed what it's chemically made up of. With chemical changes, it changes from one form to another, and you'll learn about what things to look for to observe those, and how the actual chemicals in there come together to create something new. So I'll just give you a couple of examples to start off with of chemical changes. So sodium is an element in the periodic table with a symbol Na, annoyingly not an S, and it's actually an explosive metal in its natural state. And then we have chlorine, which is a poisonous gas in its natural state with the symbol Cl. And then they can join together in a chemical reaction, and because they've actually chemically joined together, they've made something new, which is salt. And amazingly enough, salt, using the symbols Na for sodium and Cl for chlorine, makes something that is a solid that is edible. So we get an explosive metal and a poisonous gas makes an edible thing that we eat in our food. This stuff here is salt. And so it's made out of 2 chemicals, 2 atoms, 2 elements, sodium and, this is not going to work. I'm trying to show you salt. It's silly, you know what salt looks like. Salt. And then another example would be hydrogen and oxygen making water. So hydrogen, chemical symbol H, is a gas. Oxygen is also a gas, chemical symbol O. And if you join 2 hydrogens and an oxygen together, you get water, which is a liquid. Pretty amazing. So this is its chemical formula or symbol, the word equation. And then you can also work out how the things fit together and why they join together using the idea of our protons and our electrons, because hydrogen has 1 proton in the middle and has 1 little electron floating around the outside, and oxygen has 2 electrons and then the other 6 around the outside. And so it actually wants to have 2 other extra electrons floating in its outer shell or energy layer to make it feel nice and stable. Same with sodium and chloride, they join together. This is sort of extra stuff really, more leading into year 11 chemistry, but it's to do with how many electrons are in that outer layer. That is the reason that they do like to join together and become that stable thing, which is salt. Because sodium just has 1 electron on the outside and chlorine has 7, and they both want to have a full outer shell to be happy. And then we can make things like water and salt. And that's really the end of my little first lesson, and I'm going to do another one with some experiments and examples of fun stuff you can do at home in your own kitchen. Over and out for now. Bye.